Welcome to Live in Freestyle Scripting Crash Course for Creatives. My name's Kevin. This is Class 2. If you missed Class 1, you may want to go back and check that out. There's probably a link somewhere in here. What we're doing in this series is we're hopefully giving you some of the technical know-how to write little scripts to help you become hackers so that you can maybe remove some of the tedious aspects of your workflow and also make some of the more accessible things available to you that you might have been struggling with before. We're doing this a little bit different. Hopefully it'll help for anybody who's never written a script before and for those who maybe struggled with it. As always, if you are a guru and you have feedback or comments, or you have questions and you're just learning, please, as always, throw those down in the comments below. Today's class is variables and functions. But before we get into that, let's take a look at your homework. So what I did is I went and grabbed a couple of homework assignments from one of the previous times I taught a course similar to this, and I thought it would be good for us to go through this just like we were in class together. So let's load that up and take a look at Maya and see what it is we've gotten ourselves into. This is the homework for 3 different students, and we're just going to go through it and see how it goes. I went ahead and made the text a little bit bigger this time, so hopefully you are able to read it a little bit better depending on the stream. And what we're going to do is we're just going to take each student. We've got these broken down into student 1, 2, and 3, and we're just going to highlight it and run it. All right, so let's take a look at what student 1 came up with. All right, student 1 came up with, it's pretty cool. It's a house, it's got a door, it's got a roof, totally completed the assignment. That's great. I'm actually going to take this and I'm going to group it and I'm going to move it off to the side to make room for student 2. Now, before we move on to student 2, let's just take a quick look because we should be able to, thanks to, sensical naming, things that make sense. We name functions and variables and everything we do in scripting, something that makes sense and describes what we're doing with it. So when we read through this code, we can see polycube. Okay, that's probably going to make a polycube. Move, polyprism, move, rotate, polycube. So just by reading through the code, we kind of have an idea of what that does. And we can actually go through it line by line, and we will do that here in a second. Let's take a look at what student 2 came up with. And remember, as part of your assignment, you were also going to take a look at some of the other scripts that were out there and see if you could identify the parts. This particular individual came up with a smaller house, still a house, we're good to go. The interesting thing is they actually took it to the next level and started doing some things with variables, which we will get a better understanding of today, which is very cool. And let's take that and let's group that and move this off to the other side. And finally, let's check out student 3's house. Student 3 made a tiny house. I am going to get rid of this outliner. Maybe? Yeah, we don't really need it. Okay, so here's our tiny house. And again, we have a house, we've got a nice yard, we've got our walls, our roof, and even a chimney, which is pretty cool. And if we take a look through their code once again, because it's written in a friendly way, we can see they're using polyplanes and polycubes and moving them, and polycones and moving those and rotating. There's some interesting ones in here. If you're new to Maya, make identity. This is a fancy way of doing freeze transforms and stuff like that. But let's go back. And I lied. I want my script editor just temporarily. I'll keep it over here, maybe on the right side here. This is not as important. I'm going to group all of this and I'm going to move it aside. All right, here we are. And let's go back to the top and just to warm up a little bit and remember what we were doing before. We're going to go through this line by line. So we'll highlight the first line, we'll run it. We'll highlight the second time, we'll run it the third time. You can see what it's doing. This is going to rotate this thing. It rotates at 90 degrees, it makes the roof. If we do another polycube, this one's not clear yet, but once we do our move, we'll see that that became the door. Then we're going to create a polysphere, and this is going to do the same thing. It's going to move it into place. Now, if we take a look at a couple things about this. First off, this is awesome. Y'all did a great job. And the reason that this is awesome is what we are doing is we are starting to build the muscle on how to write scripts in Python. So if you got this far, you successfully took a bunch of mel commands and you went and you started building those muscles so that you know what the syntax is, how it's written is what syntax means, how to write Python to create a polycube, to do a move command. The other thing that's really cool about what each of these students did is they even went through and cleaned up their scripts. So if you recall when you were running mel, it actually printed out a bunch of comments along the way. And those, they went through and they removed all of those, got rid of them all, so we were just left with a nice clean little script that we can use to build a house. Another thing that's super awesome about this is they all did it differently. And that's okay. This is scripting is going to be, you're going to have your own kind of style to it. And each one completed the assignment. Each one made a different house. And even the way they did it, the way they wrote the code and everything was different. But it doesn't matter because it successfully completed the task. And when we're writing scripts for ourselves and improving our workflows, it doesn't matter. And when it works, great. That's all we're trying to get to. The other thing that is great about this is kind of step one, right? We went through line by line, we built a house. And what we're going to be doing is we're going to be building on top of this as we go. And what I mean by that is if you build a house and I build a house, and then the next assignment or 3 assignments from now, we need to create a neighborhood, I can use your snippet of code, I can use my snippet of code, and we can create a neighborhood out of 2 or 3 different houses instead of having the same cookie cutter house all throughout. But we're going to layer and build on top of this, make our code more efficient, and all those things all throughout this course. And we're also going to be moving away from houses as well. This is just the starting ground, so don't get too worried. We're going to be building some fun tools as we go as well. Let's just double check to see how we're doing with our notes. So at this point, one of the things that came up, question that is often asked is, a student asked, do we need commands in front of everything? And it's a very good question. And remember, the commands that is written here is basically a way for us to access the Maya commands library. So we have access to the polycubes and things like that. So mostly the answer is no, but there is a little bit of yes. You need commands in front of the actual commands that you're running in this case, because you imported the Maya commands as a library called commands that you can then access. If you imported this Maya commands as import maya.commands as MC, then what you would need to do is you would need to do mc.move. So however you decide to name that library when you import it, that's how you're going to access it. If you were to import math, because this is a standard library, you just get math.whatever whatever it is you want to do. So it depends on what you're importing, and in this particular case, a really good question. Now, with this, what we're going to do is we're going to kick off a new tab, and we are going to start to talk a little bit about variables. Now, I'm going to keep this. No, I'm not even going to keep this here. We'll just go ahead and create a blank slate. Now, as I said, we're going to be talking about variables and functions today, and you kind of have an idea of what they are because we were at least able to identify them. So as we're talking about variables, let's take a little bit of step back and understand both variables and functions. They are going to help us make our scripts more efficient and more reusable. That's kind of like the big picture goal. But let's start with the definition of a variable according to Python. I love this. Python definition: a symbolic name that is a reference or pointer to an object. That is absolutely awful and useless. Maybe if you're a guru, that is helpful and makes sense to you, but for me, not so much. So let's just throw that out. And this is what I want you to think of. A variable, I want you to think of a variable as it's a bucket. Okay, so you imagine you have this bucket, and just like a normal bucket, you can put things in the bucket and you can take things out of the bucket. And so we are going to think of a variable as a bucket that stores something for us to use. Now, there's a couple interesting things about this variable bucket that we're creating. When I have, let's say I have 3 buckets. I have a bucket that holds water, one that holds wood, and one that holds dirt. So I can store different things in each bucket. But if you are holding 3 buckets and I need the one with the water in it, how do I know which one to ask you for? So our variable buckets are special in a couple different ways. One, we can put something in it, we can take something out because it's just storing a value before it, but we can also name our buckets. Just think of it as putting a label on it. So that if you're standing there and you have 3 buckets in your hand, I can say, I need the bucket called water, or I need the bucket called dirt, or whatever it is. Now we're gonna actually take this and make this a little bit more practical, but overall, a variable is a bucket. It's a variable bucket that we're putting a value in that we're storing and we can use whenever we need to. And we get access to it because we know the name of it. Now you know this because you already saw part of this as part of your homework when you went through and you identified code. Most anything that had an equal to the right of it, that was what we said was a variable, but we didn't really explain what it was. So let's take this and talk about this. We are going to create 3 variables right now, okay? And the way this works is when you define a variable, you first give it a name. This is the label on your bucket. So our first bucket, we are going to call first name. Now that we have a name, we need to tell Python that we want to put something in this bucket. So that's where the equal sign comes in. And then we want to say what value we're going to put inside our variable bucket. And in this case, I'm going to use double quotes and I'm going to use Kevin because that's my first name. Okay, this line defines a variable called first name, and it assigns or it puts a value of Kevin inside the variable bucket. So if I want to print what's in the bucket or in the variable, I can do print and I can use first name. Now, if I highlight this and I run both of these lines of code, you'll see it prints out the name Kevin. So here's what happened here, line by line. We created a variable called first name. We set it equal to, we set the value to Kevin. Then we ran a Python command called print. When print came in here, it looked and saw the variable bucket first name, and it said, give me the value that is inside that variable bucket so I can print it out. And that's exactly what it did. Now, let's make a few more variables, okay? Let's take and create a variable called spare ammo. Let's say you're making games. And we're going to set its value equal to 8. So you have 8 rounds of spare ammo. And I'm going to create another variable called dollars. And we're going to set its value equal to 5.0. I have $5.0. Now, at this point, I have defined 3 variables. What are the names of those variables? Hopefully, you're looking at this and you say first name, spare ammo, and dollars. And now I'm going to ask you, what is the value in the spare ammo bucket? You're going to hopefully look at that and you're going to look at what's to the right and you're going to say 8. So inside the spare ammo variable bucket is a value of 8. Dollars has 5 and first name has Kevin. And we can print them all. So if we print spare ammo and we print dollars and we can print first name, which we already did, but let's just do it again for consistency. So print spare ammo, notice it prints 8. Print dollars, prints 5.0. Print first name, it prints Kevin. So we've now defined 3 variables that are first name, spare ammo, and dollars. Now there's a couple other things about variables that we can do. Okay, so we can change the variables. So right here, if I define dollars as $5, and then after we print $5, let's just say I take $1 away and now I have $4. So I can reassign it. I can change dollars, what's the value that's in the dollars bucket, to 4. And now if I print dollars, I'm gonna copy this and paste it, you'll notice that it prints 4. I can do even more. Let's say that I have a variable called my allowance. And let's say that that's equal to $2. Not moo allowance, but my allowance. My allowance. I've got to make sure I define it. Okay, it's $2. I can take, if I start from the beginning again, if I go all the way down, you'll notice that this is going to print 8, 5, and Kevin because I started from the beginning. Now, rather than setting dollars equal to 4, what I'm going to do is I'm going to set dollars equal to 5 plus my allowance. So right now it's 5.0, and I'm going to go plus my allowance. And then I'm going to print dollars. Now, this is important. What we're doing here, we have a bucket called dollars. When we start, let's go back to the top. When we start, we have a variable bucket. It's a variable called dollars, and inside of it is 5. The value is 5. We print it, and then what we do is we say, oh, you know what? I want to change what's inside that variable bucket. And what I'm going to change it to is going to be 5 plus my allowance. When you run this line, Python looks at this and says, well, 5 is no, I know because it's just a number. And it says, I need the value that's in my allowance. And it goes back up here and it says, ooh, my allowance is 2. Maybe it doesn't say ooh, maybe it just says 2. And then it says, great, so I can add 5 plus 2. And now, oops, I deleted it. Now the value that's inside dollars should be 5 plus my allowance, which is 2. So what should print when I run dollars? Hopefully you're thinking 7. So now dollars, the variable dollars, has 7 in it. I think a better name would have been piggy bank or petty cash or something like that, but that's okay. This worked. So now we have our allowance. Now let's take this one step further. The same way that we added 5 to the value of my allowance, generally speaking, it would be more useful if we could take what we already have in our bucket and add or subtract from it. So how can we do that? Well, what we can do is we can say dollars is equal to, now this whole left side is just saying the variable bucket dollars is going to get a new value. That's all it says. The work is actually done on the right side. So what are we going to set it equal to? I'm going to set it equal to dollars. You're like, wait a minute, I'm setting dollars equal to dollars? It's okay, I can do that. I can do that in math, I can do that in whatever. So right now, if I did nothing else, dollars would be getting set to the value that is already in dollars. So there would be no change. But I'm going to change it and I'm going to add my allowance. So at runtime, when Python looks at this, what it does is it says, we're going to take a variable called dollars and we're going to set its value equal to dollars plus my allowance. Well, at this point, what is the value of dollars? This is a trick question, okay, because there's some trickery that went on. Let's go back in time. Dollars is 5 here. That's what we set it to initially. Then we printed it. So we can see it's 5. But don't forget, we had this line of code here as well. So now, when we run this line of code, let's put another print in here. Now, dollars is equal to 5 plus my allowance, and my allowance is 2. So now dollars is 7. All right, and then I'm gonna try to work on all right. Then we're going to take dollars and we're going to add allowance. But remember, dollars is 7 now. It's not 5. It's 7 because we changed the value that's in the bucket. So when we add 7, when we add my allowance to 7, we get basically 7 plus 2, which is 9. So if we run this line now and we print dollars, we get 9. Now we can also take dollars away. We can basically do the exact same thing and we can set the value of dollars, the variable dollars, and we can set it equal to the current value of dollars minus my allowance. And then that's going to put us back to 7. Now, if we wanted to, if this is particularly confusing, you could do this exact same thing and create a new variable called piggy bank. And now what we've done is we've created a new variable bucket. We have nothing in it right now because we haven't assigned it. And what we are going to do is we've labeled the new variable bucket piggy bank, so we know how to get to it. And we are going to assign it a value of dollars minus my allowance. Keep in mind, dollars right now is 7. So if we take 7 and we subtract 2, we get 5. If we print dollars, it prints 7. Take note, read what's happening. We're printing dollars. If you were thinking, why didn't it print 5? That's good. All that happened was we printed dollars. We wanted to print piggy bank too. So let's print piggy bank. Okay, so that's a quick kind of setup, different framework, a different way of thinking about what a variable is and how to kind of wrap your head around it. There's one call out I want to make before we move on. You'll notice that as I was assigning values to our variable buckets, I always said dollars gets 5, my allowance gets 2, or I said spare ammo is set to a value of 8. The reason is, if you go through a proper computer science course, the equal sign has two purposes. One is to set the value of a variable, and one is to check the value of a variable. And to be clear about which one you're doing when you're having conversations, you might hear people say assign or get, right? Spare ammo gets a value of 8, or spare ammo is assigned a value of 8. If you hear me saying that, just understand that it's for clarity later on, and that will become clear in a couple classes, but just a quick note about that. At this point, we've done a lot of work with variables already. We have our bucket analogy that's hopefully a little bit easier to get around. Now let's talk about the kinds of things that we can store in our buckets. So we already know if we can kind of delete all this stuff. We can kind of go back. Now, let's start with the most basic type that you can store in a variable bucket. And that is an integer. I think this is probably the most basic one. But if we go back to grade school math, or basic math, these are all whole numbers. Okay, and they can be positive or negative or 0, for example. So you could have a -5, -1, 0, 1, 5, 9, etc. That's an integer. These are used to store values of whole number things. For example, the amount of ammo you have. You're not going to have half a bullet. So generally speaking, your spare ammo is going to be a whole number. The day of the month, generally a whole number. Is it the 1st, the 3rd, the 15th? Your age, also probably a whole number. All of these kinds of things, generally speaking, are going to be whole numbers. And as I said, they can be positive or negative. So we've already used this once. We set our spare ammo to a value of 8. Like I already mentioned a bunch of things. A house number. A house number is probably a good one, maybe. But anything you can think of in a contact sheet, for example, phone numbers, those are whole digits. Generally, you don't see those as 2.5, whatever. Now, so integer, probably our most basic. Our next one that we're going to talk about is either a decimal or a float. Now, this is going to get called decimal or float. It's largely dependent on the programming language that you're working in. It doesn't matter. As long as you understand that means it has a decimal in it. A float is just another way of saying decimal. And these numbers also can be negative or positive or 0, but the difference is they have an actual decimal point in it. So this is negative 3.5, negative 2.0, 0.0, 1.3, and 10.0, for example. Things that we're going to use decimal for, dollars and cents. That's a good one. Another one might be light intensity. Another one, interestingly enough, Maya keyframes are decimals because you can technically keyframe on the half frame. So if you go to 1.5 and you want to put an in-between in, you can. So Maya keyframes, believe it or not, are floats or decimals. And then we, like I said, we already did my allowance and stuff like that. So that's a good one as well. Now the third type, and I think we're basically gonna go with 4 of our standard types, if you will. Our fourth one is pretty straightforward. This is usually called a string. Sometimes you might hear people call it characters, but in general, it's a string. And the general gist with this is these are, it's a series of letters. And these are things like Kevin, hello. And the interesting thing about strings in Python is you can use single quotes or double quotes as long as they match. So we could use Jacob, blue. Now notice I started with double quotes and try to finish with single quotes and it doesn't highlight properly. So you cannot mix and match. They have to start and stop with the same. So we can go blue, for example. Now each of these things I can print. I can print out a decimal, I can print out a first name, etc. Again, you saw that in the previous example. Fourth standard variable type. This one's interesting. Generally it's called a Boolean. The general gist or the thing to know is this is either true or false. And we use this for things like we're generally going to use this, for example, like let's say you had a character in an experience and you wanted to know if they were a melee character. You could define a Boolean value called is melee. You could define a Boolean value is married if you were creating a contact sheet. So if you wanted to, you could say is married, and you would set its value equal to true. Or you might have is married and you could set its value equal to false. Either one, depending on what it is that you want. So anything like that. Are the lights on? Is it day? Is it night? Simple on and off type questions. These are going to be true and false. Okay, so that walks us through the 4 standard variable types. And the point of this is to outline the types of things that you can store in your variable buckets. We're not putting dirt and water and all that stuff in our buckets. We're putting actual numbers and strings and things that we're going to be able to use in order to create tools that we want to in Maya. So let me double check my notes and see where we are. Okay, let's start a little bit of an adventure. Actually, before we do that, we're gonna talk about 2. I'm gonna call them complex or compound types of variables. So we have integers, numbers, floats, decimal numbers, strings, and booleans. Now, there's 2 others that I want to introduce you to. We're not going to go into, but I want you to be able to recognize them because you're going to see them everywhere, especially if you're working in Maya, and it's important for you to understand them. One is called a list. And sometimes you'll hear people refer to this as an array. The general gist of this is it's easy to think about what it is because a list is just like you are creating a grocery list. It's a list of things that you want to buy. It is more than one thing. And the reason why I called this complex or compound is because your list stores a group of one of the other types. One or more, but for now let's just call it one. So here's what I mean. Let's create a variable called grocery list. Grocery list. Or yeah, sure, that's fine. And what we're going to do is we're going to set it equal to, and this is how we define a list in Python. It gets square brackets. Now, this grocery list is empty. There's nothing in it. It's like having a blank piece of paper. If we want to put something in it, what we can do is just in parentheses, not parentheses, quotes, let's define some things we're shopping for. And let's just say we're going shopping for fruits. So we're going to get some apples, we're going to get some oranges, and we're going to get some lemons. Now, I did that fast. Basically, apples is a string. You're going to encapsulate it in quotes. You're going to put it inside quotes. And between each one of these, you're going to put a comma. As long as your list is, just like you were writing out a list of things in a sentence, you just comma, whatever the next thing, comma, just don't forget your quotes. So this creates a list. Now, the cool thing about this is if we print our grocery list, it will print all three. So we have access to all three of those at the same time. Now, if we wanted to take this back to our bucket analogy, this is a special kind of bucket. And all it is when you look inside of that bucket, rather than having one value, you can have a whole series of values. And so when you ask for the information, in this case, when I ask for grocery list, Python knows that that's a special bucket that has a list of things in it, apples, oranges, and lemons. And it knows that what it needs to do in this case is print out that list. I'm going to take this a little bit further. No, I'm not right now. That way you can recognize grocery list. We'll come back to grocery list in a second. The last compound type I want to talk about is called a dictionary. You might see these and it'll be good for you to be able to recognize these. And let's say we're going to create a dictionary of birthdays. No, favorite colors. Favorite colors. This one works the same, much in the same way. The difference is this one is defined with swirly braces, and we get each item in there is actually 2 items, and it's a way for us to associate them. So here's just stay with me here for a second. Let's pick a person, Kevin, and let's give them a favorite color of blue. Okay, now let's take another person. Let's take Jane. We gotta put it in quotes, Jane. And we're going to make her favorite color orange. And let's take Jack. And we'll make favorite color, Jack's favorite color is black. All right, this is how you define a dictionary. What's important to understand is we do this when we want to associate a key value with something. Right here, the key is the person's name. Kevin, Jane, Jack. If I wanted to know what Kevin's favorite color is later on, once we understand how to use dictionaries and things like that, I could ask favorite colors to tell me, hey, give me the information for Kevin, and then it would come back and it will say blue. Or what is Jack's favorite color? And I can get black. I don't want you to necessarily understand everything about this. I just want you to be able to recognize the difference between a list, the square brackets, and a dictionary, which has the swirly braces. We'll get into using those later. For now, we're going to take a breath, take a second, and we're going to start to use some of our variable information. And we're going to do that by going back to basics. And what we're going to do for the rest of the class is we're going to start to build a nudge tool, just line by line, and just see how it goes. So one of the first things that you probably want to do with a nudge tool is you want to move an object. In this particular case, the object that we're going to move is, let's just move one of our houses, for example. So where's my, I'm going to redock this if I can. Okay. This was the 4th house that we made. We have all of them here, so you can see them. Okay, so what we're going to do is we're going to start to make a nudge tool. So how do we do that? First, we need a command, and we already imported our commands, and we're going to use commands.move. And what we are going to be moving is we're going to be moving a distance. And because we're doing nudge, let's just say we wanted to nudge the house up because the foundation's too low. All right, so we're going to move it up 0.0, and we're going to do a nudge. So we're going to move it up 1 unit at a time, and nothing in X or Z. We're not moving back and forth. We're only moving it up. And the object that we're moving is going to be group 1. Group 1. And we're going to go ahead and do it relative. Now, let's take a look at this. Right? You didn't realize it, but if you were using relative in your homework, or you ever typed true or false in any of the commands that you copied, that's Boolean. That's a use of the Boolean variable type that we were talking about earlier. And all it says is, when we do this move, we want it to be relative. If we run this command, this is going to move group 1 up 1 unit. So I'm going to highlight this and run it. And you can see our house moved up. It's pretty cool. So we just got our first command, first section of our nudge tool. If you wanted to, you could imagine that this play button in the top right is the UI that we worked so hard on to create. And we assign this command to it. And every time we press play, we're clicking the nudge button. It's kind of cool. If we wanted to move this house back down, we can simply change the number to -1, and we can rerun the same thing over and over, and this will nudge it back down. So we know how to make move up, and we know how to make move down. So let's do this. And we're going to comment our code as we go. Trust me, we're going to get back to variables here in a second, step by step. So this is going to be move up. And then I'm just going to copy this, and we're going to call this move down. And move up should be a +1. Move down should be a -1. And then let's do move left and right. So copy the same code again. So we have move left. And left is going to go -1 in X, 0 in Y, etc. And then move right. Gotta make sure our comments are good. I also need to make sure that you all can read this. Okay, great. And we're going to go 1 to the right. All right, so now we have defined 4 commands. We're using 4 commands that we can use to nudge our house around. If I want to move the house up, I can highlight this one, run it a bunch of times, down, same thing. Left goes the other way, and right, we can come this way. This is cool. That's great. And now we can move group 1. Here's the learning. The way we have written this is often referred to as hard coding. What that means is this command that we've written here is only capable of moving group 1 up 1 unit. We've hard coded it to only work with group 1. Wouldn't it be cool if, or before I get to there, if I wanted this to work for group 2, I have to go in here and I have to change every single group 1 to reference group 2 now. Now my code will work for group 2, and I can move group 2 up, I can move group 2 down, etc. You're getting the general idea. Now, this isn't that bad to change group 2 or group 1, because I only have 4 lines of code. But as your scripts become more complicated, more complex, or more intricate, you might have group 2 all over the place, and trying to use it trying to make an update just to move the 3rd house. Wow. So wouldn't it be cool if we had a way to do this? I hope the lights are starting to go on, because where I'm going next is we have a variable. So what if instead of hard coding the move command to use group 2, we changed it to use a variable instead? So we can change it to use a variable instead. All we have to do is define a variable, and this is going to save us a bunch of editing, and it's also going to make all of our code more reusable. So if we create a variable, what might we name this variable? We want to be descriptive. We want to know what it's going to do. We want to generally do this with all the stuff we do, so when we go back to read it, we know what we were thinking at the time. Or if somebody else comes to read our script, they can figure out what's going on. So let's make this very plain and obvious. All right, and we are going to call this object to move. Super verbose, but super clear. And that's okay. As we get more along the ways, and depending on who you're working with and stuff like that, you can kind of change out your name. But right now it's great to be clear for a concise understanding of what's going on. So the object that we're going to move right now is going to be group 2. Let's define this as group 2. Group 2. Now, this line, as we were doing above, is defining a variable bucket. It's a variable. Eventually I'll stop saying bucket, but for now I'm just trying to keep this consistent. We're defining a variable bucket, and it's called object to move. And it gets a value. It is being assigned a value, a string value of group 2. So now all I have to do is I can go through here and I can replace all of these, and instead of having it group 2, I can replace all of these to be object to move. Now, I missed a quote. What happens is when this move command gets called, it comes in here and says, okay, I'm going to call the move command. The value I'm going to give it is 0, 1, 0. And then I'm passing a variable. I'm saying use the variable object to move. When it gets run, Python says, oh, what is inside the variable bucket for object to move? That's what I'm going to use. And in this case, it's group 2, and then relative is true. So if we just define this, now our move command moves group 2. If we change our variable to group 1 and we run the same command, you'll notice group 1 goes. If we change our variable to group 3, now group 3 is moving. So we have taken 4 lines of code and we've variabilized it, for lack of a better word. We've converted it to use our buckets so that now if I want to make a change, it's very fast for me to change which object my nudge tool is working for. That is like just the tip of the iceberg of why variables are powerful. It helps us not have to rewrite and reuse and make edits all throughout our code. What's going to happen when you start, you're going to write your code, your little scripts, hard-coded. You're going to do exactly what I did initially. You're going to copy the Maya command, or you're going to think in your mind, I'm going to move this thing, this is the value I'm moving it by, this is what I'm moving, and then all of a sudden you're going to look at it and you're going to realize that you're copying your code over and over again, and then you're going to think, oh, I could use variables so I don't have to edit each line. Perfectly normal. That's part of building these muscles. It's part of the learning process. Do that. We're kind of fast tracking some of the reasons and stuff like that because, like I said in the beginning, we're trying to wreck the learning curve here. Okay, so let's see how we're doing in tracking in our class notes here. So now we're using our variable. That's great. Now let's also go ahead and variabilize the values. Now, we're not going to get quite the win yet out of doing the values, but I still think it's just good practice. So how would we convert this move command to be to use variables instead of a hard-coded 0.0, 1.0, etc.? All we're going to do is define some variables. So let's make 3 variables: offset x, offset y, and offset z. And I'm going to set these equal, not minus, equal to, in this case, 0.0, 1.0, and 0.0. And then I'm going to replace the hard-coded values in our move command to be offset x, offset y, and offset z. Now, this is the exact same thing that we were doing before. The difference now is we're using variables instead. And whenever we run move on group 1, it moves it up. If we wanted to, what we could do for move down, because x and z are already 0, we don't have to do it. The only thing we need to change is y. So if we just change y to -1, and we can just copy this command. I don't even have to retype it. I can just copy and paste it. Okay, I'm going to do the same thing here. Copy and paste it. Because I know now that this is going to be the command that I use over and over again, and it's super easy for me to copy and paste it wherever I need it to be. Now when we go left and right, it's going to be a little bit different. So when we move left, we're going to go 1.0 and 0 in y in this case. Or actually left should be -1, my mistake. And then right, the only thing that's changing is the x value, because this is being done in order. So this is 1. So now we have move up. This moves our house up. We have move down. This moves our house down. And we have move left and move right. All we're doing is executing our code, and we have basically created little snippets that we could use for buttons to nudge an item. This might be great, for example, if you're working with animation and you have an IK control and you need to nudge it over just a little bit, or you have a vertex on a model or a camera. There's lots of different ways that you could use nudge. This is just an example, and it's a good bite-sized example of how we can start to use scripts to, even on our second day, create something useful. So let's see how we're tracking in our list. Okay. I wrote down some questions that some of the students were asking along the way. One of the things that was asked along the way was a question about the list. And it's like a variable, and instead of storing one value, it stores a list of values. But what happens when you print? Well, I already showed you what happens when you print. It prints out the whole thing. And then, but here's the follow-up. So now that we've kind of started our variables, we're using them and stuff, let's go to this question. So they first asked, what happens when you print? Well, I showed you what happens when we print our grocery list. Grocery list, gotta be able to spell it, list. It prints out apples, oranges, and lemons. Now, very astutely, the next thing that they asked was, how is it possible to only print one of those items? It's a really good question. And it's a little bit ahead, but I still want to show you how it works because it's going to take a couple tries when you're working with lists to understand how this works. And we're going to do something here in a minute that is going to use lists, and I want this to be familiar for you all. But if you don't get this on the first try, don't stress. We're going to be doing an entire class of working with lists and dictionaries and things like that. So when you look at a list right now, there's a couple things that you should just know right off the bat about it. First off, when you look at this particular list, you have 3 items. The name of the variable that holds the list is called grocery list. The question is, how do you access one of the 3 items? The way this works is Python has a way of indexing. It's an address for each of the items in the list. And the address, the index, is always the same. It always starts at the same number. So I'm going to just type it up here for you to see. The first item in your list is at index or address 0. The second item in your list, I'm hoping you're going to guess, what would the second one be? It would be at address 1 or index 1. The third item is 2. The fourth item is 3. Basically, it's literally the digit, but it all starts from 0. Now, most of the time, a list index or address will start at 0. And I would say most programming languages, scripting languages. So whether you're learning Python or Mel, or you're using this to learn and launch off to do something else, generally speaking, a list or array starts at 0. There's a couple of exceptions, but for now, let's just go with that. So what that means is, if I ask you, if we're looking at this, I am going to ask you a few questions, just like I did in that classroom. And I want you to try to answer them in your mind. We have apples, oranges, and lemons. What index number is used for lemons? Hopefully, looking at our little cheat sheet, you're saying 2. Right? What fruit is stored at index 0? Look at index 0, and hopefully you're saying apples. All we need in order to print a single item from this list is a way to tell Python which index we care about. And we can do that very easily. And fortunately, it is almost exactly the same as creating the array. Or the list, I'm sorry. If I want to print the item in address or index 0, all I do is create a bracket, just like we do when we define the array, and I'm going to type in here 0. Now, we've already seen that if we print grocery list, it prints all 3. If I print grocery list bracket 0, what I'm telling Python is, take whatever is in the list at index 0, and that is the information we care about. And so print is going to ask the grocery list for the item at index 0, and that's what it's going to print. You'll notice it prints apples. So I'm going to ask you a question. What prints if I print grocery list index 2, address 2? Hopefully you're thinking, looking at our little cheat sheet, you're thinking lemons. Now we can extend this. We can change this. We can change this to be bananas now. Bananas. And maybe blueberries, and kiwi. So without the cheat sheet, what index do I need to use to print kiwi? I want you to take a look at it, take a second, and figure out what number you need to use to print kiwi. Hopefully you're just going 0, 1, 2, 3, 4, 5. 5. Hopefully you got 5. Right, so if we print grocery list 5, and I have to redefine grocery list. Notice this is a trick. I just typed it in. I have to redefine grocery list, and just to prove it out, if we print grocery list, you can now see it includes kiwi. If I print the item in 5, it prints kiwi. Also, notice the item in index position 2 has not changed. If I print grocery list index 2, it still prints lemons. It doesn't matter how many I add to the end, index 2 doesn't change unless I move it or change it. So it's basically printing 2. So as part of the answer to this particular student's question, you can print the entire thing, or you can access and print a single item in your list. And this is going to be very, very powerful because generally speaking, whether you're working in Maya or Houdini or Unreal, it does not matter. You are generally going to be working with a large group of things. You are probably going to be working a lot with lists. And lists are going to be used for things like your keyframes, the objects that you currently have selected, the number of players in the game, the number of nodes that you're using, or simulations you want to run in Houdini. I'm not super familiar with Houdini, but there's, generally speaking, we are using scripting because we're doing this more than once. We're working with more than one object, and this is going to help us do this 100 times or 500 times or 10 times. If we were only doing it once, we probably wouldn't need scripting. So anyways, that is a quick little off step to define a couple things about lists. Now this becomes important because we're going to make a change to our nudge code here in a second. Let me double check our notes. Let's just double check our notes real quick. All right. Now, when we first started, we had quite a few lines of code. We're slowly getting it down, and we're going to make it even more useful. All right. So let's do this. Right now, we are using this variable object to move, and we're setting it to group 1. As useful as that is, it still requires us to type something in. Wouldn't it be cool if it just moved the item we had selected instead? So you know how to do this. You don't know you know how to do this yet, but I'm going to show you you know how to do this. In order to do that, we need to use a command, a Maya command, and we probably should bring up our command reference. All right, and the command reference that we are going to be, what we're looking for is a command called ls. ls is sort of a short for list, or it's kind of like Linux. If you've ever used Linux, ls will be list stuff out. The way ls works is you can see this returns the names of the objects in the scene. Cool. So now we know what the command is. Let's put this back over here, and let's use this command. And what we're going to do is let's just run it once so we know what we're working with. Commands ls. If I run this command, I'm going to clear my history so you can see what happens when I run this. This is going to list everything in the scene. Now, that's not super useful because we want just what's selected. But step 1 is we've run a command that lists everything in the scene. The thing that I want you to note about this is it's actually creating a list. And you know this because when you look at the result, there's a bracket here in front of it. Okay, so we're actually getting back a list, and that makes sense because there's more than one item in the scene. We wouldn't want to get back, if I asked you for a list of everything in our Maya scene and you handed me, let's say there are 100 items, and you handed me 100 buckets, that would be insane. But if you handed me one bucket with 100 things inside of it, now we're talking. Now we can work. All right, so we've got commands ls. Now we need to make this a little more useful, and to do that, let's take the let's look at our command reference again. And I happen to know, so we're going to fast track this a little bit. I happen to know that the one that we're looking for is called selected, and it's in here, and it's the selection, and it takes a flag of SL. Okay, great, we can totally work with that. So let's move this back out of the way, and let's double check that all of our stuff is still working. Great. So now if we add a flag to our ls command of SL and we say true, that means we want to do the selection to be true. If I run this right now, what's going to print? And this is hard to know because you can't really see in my screen, but right now I have nothing selected. So if I run list what's selected, it's going to return nothing. And you'll notice the result is an open bracket and a closed bracket. It basically is returning an empty bucket. There's nothing in it. But if I pick group 1 and I run the exact same thing, look at the difference. It returns group 1. Okay. If I pick groups 1 and 3, it's going to return 1 and 3. Now, at this point, one of the students generally asks, does it matter the order in which you select things? Actually, it does. You'll notice that right now the result says group 1 and group 3. If I change this and I pick group 3, then group 1, and I print again, notice that it prints group 3, then group 1. Now, this is also very cool. Generally speaking, in Maya, the order in which you select things is the order they get stored in your list, and you can use that when you're creating your tools, trying to figure out, for example, let's say that you picked 10 items and you wanted to align it to the first item. Well, now you know that the first item is what you're aligning to, and you know how to get to the rest of them because the other 9 items in your list you have, and you can just align them to the first one. That's an example. There are some exceptions where the order is not super reliable. So for example, vertices, sometimes it can group them together just because of the way vertices work, but generally speaking, for simple selection, the order does make a difference. Great, so we have this command, and it is listing what we have selected. Now, to make this useful, we want to store this in a variable. We're going to create a bucket to store this information. We're going to call this bucket selection. Selection is equal to. So we have now defined a variable called selection, and we're setting its value to be the result of the command ls. That result is going to be, just like we already printed, what is currently selected. So if I run this line, you'll notice that we have selection, and if we print selection now, you'll notice that the value inside of selection is group 3 and group 1. Okay, perfect. Well, based on the conversation that we just had about lists and being able to pick a single item, let's just say that we only want to move the first item, or let's just think that our list is only going to have one item in it as an example. How do I access the first item in a list? Quick refresher, if we go back to our cheat sheet, our list has an index or an address system, and the index of the first item is 0. So if I want the first item, I'm going to type the name of selection, just like we have here. So if I wanted to print the first item, selection, and I'm going to use my bracket, and I'm going to say address of 0 or index 0, and I'm going to print that. You'll notice that it prints out group 3. Okay, if let's just make sure we've got just one for now. Okay, we're going to redefine our selection. We're going to print the selection, and then we're going to print just the first item. Notice that it prints group 3. Now we have access to the first selected item. We can use that as our move to object. So let's do this. Rather than printing it, we're going to take our move object to move, and we're going to set it to the first item in our selection list. At this point, all of this code is now usable for whatever we have selected. I no longer have to change anything. And I could have a whole new group that I never had before, and I can now reuse this code for group 4, for example. Because if I have group 4 selected, what's going to happen is selection is going to get the value of whatever's currently selected and put it in a list. Then object to move is going to get the value of the first item in our selection list. And then we are going to move object to move, which in this case was the first item. So all of this has now enabled me to move whatever I have selected without doing any extra work, just by clicking the buttons. Okay? So we have successfully used and introduced the idea of variables, and we're starting to understand some of the efficiencies and why we like variables, why it makes it easier, and how they're going to make it so that our code snippets are reusable in multiple places. Don't worry about it. Your homework tonight is going to involve this, and we're going to get into that a little bit. Let's double check our notes and see how we're tracking. Okay. We have one very brief introduction to a function, because this is part of the extra credit for your homework. And the first time somebody tried to teach me algebra, I didn't understand it. It wasn't until the second or third time I heard it. Same thing with foreign languages. The first time somebody said something to me in Spanish, I didn't understand it. By the third time they said it to me, it finally clicked. And that's the same thing here. So if functions don't register tonight, that's okay. The whole point is you've heard of it, you've seen it. It may not click tonight. It may click on a different day or in the next class or whenever, but we're going to start with defining it. Now, you already know what a function looks like because we identified it as part of being able to just recognize it in our code when we were looking on the internet for different types of code. And you should remember, hopefully, that it is created or recognizable because in front of a function is the word def, short for define, maybe. I'm not entirely sure. It could be definition, whatever, but we're going to think of it as define. So def is short for define, and we're going to define a function. And in this case, I'm going to define a function called hello world. Okay, and let's just print hello world in here. Now I just went really fast, and that's okay. So let's talk about it, a couple things. When we define a function, just like we do with our buckets and we give them labels, we need to give our function a name so that we can access it. Now, let's take a step back for a second. Why do we want to be able to define functions? We want to be able to define functions so that we can reuse chunks of code. For example, let's say you wrote a chunk of code that built a house and you needed to build 20 houses. You could copy that code 20 times, or you could take that code and put it in a function and use that function 20 times. It's a lot easier to use a function. And what's going to happen as you start scripting is you're going to write it out the normal way, the slow way at first, and that's normal. And then all of a sudden you're going to realize you're retyping the same thing again. And it's going to dawn on you, wait, I could just make a function out of this. And then rather typing these 20 lines of code every time, I can just call my function. So a function is a way for us to reuse a chunk of code, much like our libraries allow us to have commands and things like that. It basically creates a chunk of code that we can reuse. It is defined by creating this or writing define. Then we need to give it a name, just like we do with our buckets, because we need to be able to say, this is the function I want you to call. And for now, it gets an open and a close parentheses with a colon. Now, anything you want to happen inside of your function needs to be indented. In this case, hello world, it prints hello world as part of our function. If I highlight all this and I run it, it doesn't actually do anything. And the reason it doesn't do anything is because all we have done is we have defined the function. We have not actually called the function yet. In order to call the function, all we have to do is type out what we named it. So in this case, we're going to type hello world with the parentheses. If I run this command now, you'll notice that it prints hello world. This is the most basic definition of a function. It's very simple. Define, give it a name, and then encapsulate all the stuff that you want to do inside that function by putting in an indent. So let's do this with our nudge tool. What I'm going to do is I am going to define a function called nudge up. I'm going to give it some quotes. And everything I want to be inside of nudge up, I'm going to indent. That's it. I've just created a function called nudge up. Let's do the same thing for nudge down. Define nudge down. Same thing, we get our colon, and we move it in. We're going to define a function for each of those. Nudge left, and we're going to go here. And then define nudge, define nudge right, and same thing. Now here's what's cool. If I highlight all of this, I'm gonna get rid of hello world at the bottom for right now. If I highlight all of this and I just hit enter, it doesn't actually do anything. And if I run nudge up now, this might error. I'm going to show you why, but let's see. If I run nudge up, I highlight this. Okay, it's working. It's cool because now it's working. And so now I can call nudge up, nudge down, nudge left, and nudge right, all with one simple line. So anywhere I want to use nudge now, I don't have to retype it. I don't have to copy and paste code. I can just now call nudge up, nudge down, nudge left, and nudge right. And nudge right, okay. This is important. Did you see what happened with nudge right? I was just about to say something. Okay. Because these are now functions, this XYZ, we need to define in each one in order to make sure that each function has the right values. So we want to be clear on this so that our nudge right does in fact nudge right. And in this case, we'll just redefine those. And now we have nudge up, nudge down, nudge left, and nudge right. Now, why we had to do that, that is a whole other conversation, but for now, just think about it as we want our function to have all the code it needs to be self-sufficient. And in this case, we need offset X, Y, and Z. Technically speaking, we should have object to move as well. So you could also technically put this in each function. And it's funny because I know we said we're using this to reduce redundancy, but we're also intentionally doing this sort of the long way because we don't know enough yet. One day, this nudge function will be 2 lines of code and it will do all the directions. Nudge up, down, left, right, everything with just 2 lines. But we don't know enough yet to do that. For now, the point here is to learn how to define a function, the parts, the word define or def, the name of the function, the parentheses, the semicolon, the indentation, and then how to actually call it by actually saying nudge up with the parentheses and then seeing it work. That's it. We're just building the muscles. This is just the start. So that is a quick intro to functions. And you can see now if I wanted to include nudge up, down, left, or right in a button, I only have to call nudge up, down, left, or right. I don't have to paste a whole chunk of snippet of code into my button that I then have to go track down and edit, etc. So functions are going to be even more powerful the more we learn. This is just a quick intro. It's part of your homework. So let's talk a little bit about where we got to today. Today was busy. We did a bunch of stuff. We were talking about variables and functions. We answered a bunch of questions. We kind of went over your homework. Let's talk about what your homework is going to be for next class. I want you to take your house code, and I want you, if we were to take a look at it, let me bring up one of our previous students as an example. If we take a look at this, okay, you'll notice that everything in here is hard-coded. The scale, the distances we're moving, everything is hard-coded. What I want you to do is I want you to variabilize your house code. Make it so that you can specify the variable as a width or the height. The width as a variable or the height as a variable, or all of those things, and then use those variables instead of hard coding them. And you can use it for the names of the objects you create, whatever it is. Find a way to use variables to make it so that the house you build can be a little more varied. You can change the size of it and build more than one type of house with the same code. That's what we're doing here. Then, for extra credit, if you can, what I want you to do is wrap your house code in a function called build house. All right, that wraps up class 2 scripting crash course for creatives. And I want you to know that help is available. We still have the live streams, hopefully, depending on what year it is when you're watching this video. The live streams are, you can check Twitter for the schedule, but as of this recording, which is, it's currently March of 2023, live streams are Sunday nights and Wednesday mornings. Sunday nights at 10:15 p.m., Wednesday mornings at 8 a.m. Both those times are Pacific Standard Time. If you have questions about what we went over in class today, if you have questions about your homework or you're stuck on something, I'm going to open up our standard game dev Q&A for an opportunity for anybody who has questions about the scripting crash course to hop in and ask some of those questions. And we're happy to help answer those and help you break down these learning curves. Once again, thanks for checking this out. If you like this content, you know the drill. Help spread the word. Help us find ways to make this channel sustainable, and just pass on the info and let us know if you have any ideas on how we can support this channel. Have an awesome time scripting, and we will see you for class 3. Take it easy.